Okay, so I wanted to make sure that we went through a couple of percent composition and molecular formula problems. I'm sorry, I didn't realize I wasn't going to be here today until yesterday, kind of late. So we're going to look, if you look on your half sheet, right where it says percent composition, molecular formula, the numbers 1 and 2, we're going to walk through those together. So the first one says, what's the empirical formula of a molecule containing 65.5% carbon, 5.5% hydrogen, and 29.0% oxygen? And I wrote them this way purposely, and it's really going to be easier for you if you follow suit. So what we're going to do is we're going to assume a total of 100 grams for the whole sample, and that makes it very nice for us, because then what we can do is, if we assume there's 100 grams, instead of writing 65.5% carbon, we change that to grams, and instead of 5.5% hydrogen and 29.0% oxygen, we change them to grams. Now we're going to use our atomic mass from the periodic table for each of these guys, and we're going to convert them to moles. So 1 mole of carbon weighs 12.01 grams. And you can double check that on the periodic table. 1 mole of hydrogen weighs 1 gram. And it's like 1.0079 something. And then 1 mole of oxygen. Now notice this is just O, not O2. 1 mole of oxygen is going to weigh 16 grams. Again, all 3 of these are from the periodic table. Okay? Now, once we do that, we are going to figure out the value of each of those. So for carbon, that's going to be 65.5 divided by 12.01. There we go. And that's 5.45 moles carbon. For hydrogen, 5.5 divided by 1.0, that's going to be 5.5 moles hydrogen. And then for oxygen, 29 divided by 16, that's our 1.81 moles of oxygen. Now looking at your notes, it says the next step is to take the smallest number of the 3. So we're going to look here. We've got 5.45, 5.5, and 1.81. This is the smallest number. So what we're going to do is we're going to divide all 3 of these by the smallest number. When we do that, that changes this guy into 1 mole of oxygen. That changes our 5.5 into 3 moles of hydrogen. And that changes my carbon into 3 moles of carbon. Now what we're going to do with these 3 numbers is we are going to use those as the subscripts. So from our percent composition, we are able to say that the empirical formula of this compound, I'm going to write it right up on top, the empirical formula for this compound would be C3H3O. That is our empirical formula. I got each of those numbers from the numbers I just calculated. That 3 came from there, that 1 came from there.